Yes, recording in progress. So I'm glad to welcome you here on this webinar dedicated to the test estimation. And I guess we can proceed with this. Somebody may be late for a couple of minutes. And also this is like a summer outside. So I guess we shouldn't expect too many participants. Everybody get their vacations, etc. So anyway, this is still better. Hey, hope you're doing well. So today I'm going to tell you a story about estimations in real life, not only in books. And also during each chapter of this story, I would like you to go with me through the little journey and try to do the estimations with me together. So I guess we'll be able to do that. And we can start for now. Let me share my screen. It should be very quick, I guess. Okay, this is it. This should be it. So again, let's think committed team to arrange this talk, and let's do this. So we go this way. The estimated time for this workshop will be up to 3 hours, maybe 2.5. Let's see. And also, there will be some little break, I guess, in an hour and a half, something like this, for like 7 minutes to grab a coffee, to just get some rest. So you won't be needed to leave this session while I'm speaking. So the main topic is, again, the estimation. Estimation is something that many of us might be hearing about, but only a few doing something in real. I'll explain why. So for my job, I'm the quality solutions architect. I am doing the pre-sales. I'm starting new projects. I'm helping to ramp it up, helping to wrap up the solution at the very beginning. And sometimes I'm being asked by clients to do some high-level or even detailed estimation about, let's say, how long it would take, how many people do we need, or what problems can we expect, and at what point. So sometimes I have to answer those questions. And some little tricks help me to do that, and I'll share them with you, of course. So this webinar will consist like of two big pieces. One piece is the classic estimation techniques that you might see in books, whatever, and also my personal approaches, tools, as you will, if you will, and ways how to do it in real life, how to do it simple. So this is what we're going to be talking about. And from my perspective, I would want to show you the real value of this. So what can be estimated? You probably know that, okay, scope can be estimated, budget can be estimated, time, and of course, return on investment. That's everybody wants to do that, but nobody knows how. Scope, time, budget, those are like a standard project triangle that can be estimated. And return on investment is something that goes with it, but never being touched. So I will explain all these pieces later on. And one more thing, test estimation and test planning is different actually activity. it's different activities, because when you do estimation, you don't have any complete data. You may have some noise data, you may have some incomplete, uncertain data, and you still guessing, suggesting, thinking about something, picking random numbers. That's all about estimation. Test planning is when you already have those numbers, you're planning to do some activities in some order. So when you're being asked the question on how do you think, what people profiles do we need to complete this job? That's planning, not estimation, because you already have all the information here. But when you ask about how long would take test execution, that's really good question. We'll see it in several minutes. But I would like to get some input from you. So I'd like to share some your issues about estimation. So I want you to go to this link, mentee.com, and use the following code, or just use this QR code to join. So just tell me what you like the most about estimation, what the main problems you have with estimation, and what the biggest question you would like to ask about during this webinar. So I would know what is the main idea, what are you expecting from me. So please share your inputs. We'll have like several minutes to read it, and I will check if you have anything to say. Okay, so I'll go here, I'll go here. That's a new tool, actually, I'd like to bring up. Very useful. So I'm going to be presenting when we have any inputs from you. So let's have some time to complete it. You can tell about your little stories. You can talk about some pain points you've been facing with, or maybe some questions that you have for a long time. So let's have a look then. Okay, so issues, changing requirements. Okay, not pretty much sure about how it's connected to the estimation. I guess you would like to estimate the time while requirements are changing, right? So I get that point. Accuracy, yes. Lack of historical data to based on, sure. That's what also going to talk about. How to take into consideration the seniority experience of the tester. All right. Yes, that's a very good question. We'll cover that too. What to take into considerations while estimation. Okay, that's completely what is this session is all about. What is better, to underestimate or overestimate? That's another good question that we need to probably will come up to this at the end, but you'll get it for sure. Unclear expectations, usually would like to know how to give some numbers, probably ranges, some averages, deviations, undisputable explanations. So we will run in a wall of, but we still need everything to know. Okay, yes, that's good point. Estimated buffer time is not enough. People will leave, get sick, etc. Right? That's very painful, because you can't just estimate everything. You can't take into account everything to do the proper estimation. How to assess that your estimation was correct? Correct. Probably it's very easy to answer. You just have to look at the end and see, to learn on your mistakes. You need to do some of them first. So that's like a short answer on this, but I would also focus on this and how to estimate work of other people. Cool. Thank you. That's pretty good input from you. And I'm gonna focus on these topics specifically. So you will have your answers. How to explain what to do with that estimated later, like not choosing, like not chopping heads or misestimation. There is an easy answer in this. How to not chopping heads and misestimation? You just should be anonymous. Just do anonymous estimation. We're going to talk about this. Convince customer that your estimation is reasonable. Very good topic. This is why we need all those estimation tools, because sometimes you're being asked, prove that your estimation is good. Why should I trust you for your values? Why? So you have to prove, you have to show how do you do that and why it can be trusted. Okay, so thank you for your inputs. Now let's switch over to the slides back so we can start. We can feel the pain of the estimation right now. So why estimations are tough? You know, every estimation usually have some variable. So you probably can always predict some work. That's completely true. You know, if you have to, okay, like if you have to make 10 cups of coffee, so you know, right? You know, like, okay, one cup of coffee takes like 5 minutes to make, so I would need like 15 minutes. Cool. But what if that is work that you're not expecting, or you completely don't know how many cups of coffee you need to make? For example, you should be making coffee for the entire evening, and you don't know how many people will show up. So you will need to give coffee to each of those. So you cannot just estimate it, right? But still, some stores, some shops are still estimating how many customers will come up and how many items they should put, on shelves. Or, for example, if this is like a some small restaurant, this restaurant should know how many food to cook to feed all the people that will come up. So basically, this is just exactly the same about testing. So if we take the entire testing work, it usually comes up to 4 pieces, right? So first piece is test analysis. This is like the phase that we're analyzing the requirements. We're thinking about the general solution of testing. We're doing some test planning. We're trying to prepare some test approach, etc. Blah blah blah. This is comparatively simple, so we can actually estimate this time. And if we miss some estimation here, it's not a problem, because usually test analysis is like pretty quick activity. It may take like, I don't know, 3-4 days, week, or maybe 2 weeks. So if you will miss 1-2 days, not a problem, right? It's like not a big deal. But if we're going with a test design, that's longer activity, but still we know already how many requirements do we have, what is the approximate amount of tests, correct? So we know how many time it will be needed to design those tests and to record them to some test management tool. So we can actually calculate that and provide like pretty certain estimate. I'm going to show you how to do this later. Test execution is also same. You just need to assume how many time do you need to complete like large hard test case, small like easy test case, and average. Just calculate this average and go with it, no problem. So you still won't miss lots of value here. So this called like a constant or work that is easily predictable, but there is always some piece that called variable, like rework, which is hardly predictable. So this is exactly the point. This is the point which makes the estimation very hard, because you don't know how many defects you will have, how many rework effort you will have, because rework, it's not only about defects. Rework is also about requirements changed, right? So you change the requirements, you have to do some rework activities. You change the design, you also have to redo something, and these takes time and money, and stretching up your milestones. So this piece of work is hard to predict, hard to estimate. And of course, if you take a look at these like work and rework pieces, that's a way how to solve it. I've seen an input from one of you about the historical data. Historical data is very important in estimations. So personally, I would say, of course, I cannot share it, but I have like a list of typical estimations for typical projects, like my personal data that I use in my work. I use, like, for example, if this is like, let's say, web project for the electronic commerce. So this is like, I have several variables regarding that. Let's say I also know that could be like a distributed team or team that's sitting once, etc. So I know many parameters, and I have collected this data for years. And one of my advices for you is to also collect this data through your career, through your work life. So the more projects you're working on, the better are your estimations, because you collect your own historical data and store it somewhere. But because sometimes you have to do the estimation and you have zero historical data, you cannot just take it. Because why you need this? Rework is kind of a number of changes multiplied by average rework effort per change, right? So basically, if you take a look below here, so if we assume only defect related work, we have like 20 days of real work estimated. And we also like can estimate the average effort per one defect is like 0.1 of 1 day. Just have a look at this. So in case we'll have 20 defects, the total work, including rework, will take 22 days. But if you will have 100 of defects, it will be 30 days. It will be like 8 days more, means that you missed your estimation by, let's say, 25%. So which is already a pain. So if you don't know how many defects to expect, you just cannot do the estimation properly, because this rework piece you cannot use. And what is interesting that it's not completely important about the exact number of defects. You just need to know some range. Let's say, well, we're expecting, I would say, like from 20 to 40 defects, not a problem. It will be not hundreds. This is very important. So historical data usually help you to define that. For example, if you have completed like 50 story points for the past release by your team, and you have like average 25 defects, so one story point is 2 defects. So this is your historical data. So if you're planning to perform 100 of story points with the same team and same constraints, it will be most likely 50 defects, because 1 story point, 2 defects. Okay, so this is something we're being afraid of, to use this historical data. We do believe that no, in last release we were bad guys. We did like many bad things, but next release will be better. You may be, but at least you will not be worse than previous release. So in this case, you also have to use your historical data, because this will be like your safe zone. Estimate can't give you the exact number. It gives you only the range. So this is what we're talking about. Okay, so this is why we feel pain when we do the estimation. So there are 2 types of estimations that are usually applicable for testing. So high-level estimations are usually serve like a guideline, like the initial estimation that can be very rough, and you usually don't care about the exact numbers. So I already provided you one example of how to do the high-level estimation. Is when, let's say, one client asks you, okay, I have this scope and I want functional testing, I want performance testing, and I want 100% of automation. So could you just roughly estimate how many time it would take for me and how many people? So there are 2 constraints. One is people, second one is time. So more people, less time, or less people, more time, right? But it's not always like that. We'll come back to this later. So you need to perform high-level estimation. Client doesn't want the exact number of days, because of course it's impossible to calculate, but just like 6 months, year, 2 years, how many? So this is what high-level estimations are all about. They help you to frame certain project dimensions, to fix the scope, the time, and resources. And usually such estimations are expert-based. So this is what I was talking about. Expert is some person who have already the experience of estimating similar projects and able to provide some certain numbers. Of course, you would say, hey, well, so, okay, like for example, I get used to this environment and I have all my, all my estimations linked to this environment. But what if I move to another country, another culture, another environment, another working culture, and my estimations won't work there? You may be right. Your estimations might not work there, but there are at least something you can step on. So this is what all about. And these high-level estimations, of course, should be quick, because you have to start project, you have to start hiring the people, you have to start some activities. And the one thing is stopping you from doing this is estimation. How many do we need? Of course, some people prefer, let's say, we don't know yet, but we have Agile Scrum, so let's like hire one team of engineers, let's start work, and then if we feel that it's not enough, we can hire another team, etc., etc. It looks perfectly from processes part, but every client would like to know how much it would cost, because budgeting stuff is very important for the clients, because it's affecting everything, the milestones, the delivery plans, etc. So it's very important to know. But detailed estimation is something about some details. This is where questions comes to game, like, how did you get this estimate? Or why do you think that's a good estimate? And why do you think we should believe you? So detailed estimation usually have some basis, have some evidence that they are based on. And such estimations help to create some plans, timelines to execute the project. So in this case, we need precise approaches. So high-level estimations are initial, quick, and expert-based estimation. And detailed estimation, they perform after initial ones. They're evidence-based, and they should be precise. So those are two types of estimations we're going to talk about. And right now, I would like to show you a couple approaches how to do the high-level estimation. So you probably heard about mind mapping, right? I personally love mind mapping. So, okay, here is it. So mind mapping. There are lots of tools to do these mind maps, but very important thing, it could like tell you is the exact scope that you have. Because when you're talking about the scope, sometimes you have like full requirement set that are very detailed, very good, and there is only 1% chance to get it, right? But in other 99%, you get something like, well, our solution will be doing this. We're not sure why and how, but well, we'll see. But we need some kind of estimation. So mind mapping is very good thing for the high-level estimation. So this is like classic decomposition-based approach. So we take one big rock and just cut it in piece by piece to understand what it's planned to do. So one more point here is that just imagine how every product is being created. Most of products are created by proof of concepts, right? So firstly, you do some kind of like high-level proof of concept. It doesn't work properly. We change the concept. We do another one, and then you probably heard about spiral models, right? So this is what about. Spiral model is the prototyping model, which means that if we don't know how our product will be working on, we just do prototypes more and more and more, and we create prototype, we see if it's good or not. If it's not, we change it again. We don't like the technology, we take another technology. We don't like the design, we change the design, etc. So we do like fast-paced iterations, like maybe could take 1, 2, 3 days per one prototype. And once we are come up to the good solution, to the good prototype, I said, well, okay, that's pretty nice. And I have a list of changes to do to this one. So this is when the requirements are born. Because when you're doing some product, some tool, some application, you not always know what this application would do. You know probably a couple of features, the basic features, but not in details. And basic features usually is about like 5-7% of the entire application. So you cannot do the estimation based on those basic features. So you have to know the scope. And if you do the prototyping thing, some requirements are not defined in the system. What I mean is you start to create requirements after some piece of product is already created and working. So there are gaps that are not being defined as requirements. So that's why 100% functional requirements coverage is not equal to 100% functional product coverage. So even if you define all the requirements in the world, you still have some gaps that are being implemented and are working in the product, but that are not mentioned in the requirements. And that's why you cannot do proper estimation because of that. So, but those problems are not in first priority right now. And also, yeah, please, if you have any questions, any notes, just put into the chat. So I'll be looking to that and answer if you have. So not a problem. Our main goal is not to just spend 3 hours here. Our goal is to learn something, is like to widen our view and our knowledge. So this is why we're all here. So please put some comments, questions, notes to the chat so we can talk. Okay, so what about the mind mapping? You can see here one piece of the application that does some things. So we see, okay, application that have admin, probably admin console or something, active alerts and account thing, and these like active alerts, probably page, have different kinds of elements, function, etc. So mind mapping is the way of reflecting the scope on paper, to have it fixed, to have it defined, to have a basis for the estimation. So let's try to do it with the committed website. So I have Xmind, by the way. This is like a good tool I use always. It's a desktop tool, but still that's like one of the most comfortable tools for me right now. So, so yes, what are we doing now is we're going to this committed website and we'll be trying to reflect this website, its own features on paper to define the scope. So imagine we need to estimate the, let's say, number of test cases for this website. So what we're going to do is create a new blank map. Let's call it event. Okay. And now we need to reflect all features that this website have. The feature is something that can be clicked, can be used, can be activated, is some function that belongs to this website. So first things that we can look here is about us, how it works, events, pricing, etc. So we go here and let's say there is about us, there is how it works, there is events, there is pricing, there is login, and there is sign up, right? So I already reflected those features here. Okay, so now I go to the main like main page, to the main page content. So I would create one more thing here. Say main page, and this main page will have sub features, right? Is it okay practice to create, for example, one mind map for current situation, one for desired one? Is better to have one entry point. It's completely okay practice to create. So it's completely not a problem to create like separate mind maps for each element. Now we have one goal, is to reflect the features of a website on a higher level. Okay, and that's all we need. So currently we have only one mind map that we're using, and here we have like a subtopic. So we have feature like join us now, and this is why mind map is also good, because it helps to avoid feature duplication. Because I guess if you click here and join us now, you'll come up to the sign up, right? Let's check it. I click join us now. Okay, I'm going to pricing. Okay, so if I go to pricing, yes, it's almost same page, but it just brings me to this piece. So not on the top, but right here. But still, it's the same page, right? So this feature is already duplicated. We can see that. So we're gonna remove it in the end. So I just noticed here that, okay, this might be a duplicate. So I'll like put underscore the beginning just to see it's a duplicate. So I go next main page. All right, so I have also join now here. Okay, I have join as pro to participate and learn more, so I can reflect it here. So join as pro and also learn more. I have it here. So those are just like a similar functions here. Okay. This is not clickable. Okay. This is not clickable too. So I just scroll down, just take a look at what I have here. Okay. Those elements are not clickable too. No problem. Okay. Join as free, join as pro. I already have it. Okay. Join us now. There is join as free. Okay. Okay, I have view all. So I'm gonna put it here too. In using this way, I'm going through every feature I have here. I see again, join us now, but I already have it here. So I won't put a duplicate here. And also I have about us, which I already have duplicated. Events, pricing, I have it here, but I don't have already public offer and code of conduct. So I'll put it all here too. Code of conduct. And what do I have there? Also public offer. Okay. Public offer. So this is what I have for the main page. Let's take a look what we have in each of those sections. So I go to about us, nothing clickable, no functions. Okay, I have only join us now, but I already have it. So I won't need to put anything here. It's just one single page without any interaction. Okay. Then I go to events. I already have like, okay, I have like join us now, and I have this picture clickable. which means the next training to be performed. So I would also put it here saying, okay, it was events. Okay, it was events. So I put it here like next workshop. So it brings me to the next workshop to be created. And this next workshop have, okay, already join as pro. We already have that feature, so no problem. We have add to calendar function, Google, Apple, Outlook, Yahoo. Okay, so this is what we're gonna do. Add to calendar, which will have already Google, what's there, Apple, Outlook, Yahoo. Okay. Apple, Outlook, Apple, and Yahoo. Okay. So I have it here. Okay, and I have also past events, but I can't click anywhere except learn more. And when I click about learn more, I go to another session being created. Okay, so I would also put it here on the same level with add to calendar, of course. So to be learn more and say navigation to okay, this is what I have here. Okay, let's go back to our website, going to how it works. Oh, okay, how it works is just symbolic. Okay, pricing. Go to pricing, pricing. Nothing new. Okay, it goes join as free, join as pro. So we see here that join as pro, join as free here on main page, right? But logically, it should be like in pricing section. It belongs to that page. So those are just links to this page. So we can just move this join as pro. Okay, just go there. Join as pro and join as free. So, and remove it from here. In this case, we don't have duplicates. We just move it here. So join us now already, we have it, so no problem. Go next, go to login. We go to login, see this form, email address, passwords, okay, remember me, and we have register and lost your password. So we have those two features. So we go here, okay, so again, so register and lost password. And also we have the click on go to committed. So we will mention here. Go back to committed. So in this case, we have it. No problem. Then we would like to go what will show if we sign up. We go to sign up. That's already some registration dialog. We select country. We also have proceed as free, as pro. And I guess if we put something like this, okay, so good. So we just proceed as free. Okay, this should be repeated. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8. It should be 8, 2. So proceed as free. Then we have okay. So this goes through our email. So here when sign up, we just mentioned it as email communication. So there is a link that comes to an email, and we should verify it. And be able to log into website. Okay, that's also works properly. So what did I miss already? Let's check public offer. There's emails, links, etc., but nothing useful. Okay, and code of conduct. Okay, so this is what we reflected very fast on the screen, right? I might, of course, miss something, so we don't care much about this, right? So we have the scope defined here. Oh yes, I forgot to remove this one. So what we have here is just list of features to be covered by test cases. And what is interesting that we already see all the positive test cases that we usually need for that, right? Because one item here can be covered by one positive test case in average. Of course, it can be split to like two, three test cases, but it will be only like different elements. But in general, it can be covered by one positive test case. So we can actually calculate all those items and say, hey, we need this amount of positive test cases. So what we're going to do now, here on slides, I'm going to show you how these work. So does it look like a work breakdown structure for you? If you remember, there is like one smart technique called work breakdown structure that works perfectly with the Gantt diagram, which basically works as a decomposition. So in this case, we take one piece and split it to the smaller ones. So in this case, of course, we have the website ready for us, and it's very easy to estimate because we see all those features. And of course, it's much faster than if we have the requirements of this website. It's faster to create mind map based on the real website than on requirements. Of course, we can take the requirements, review them, and use it again, but it may take some time. So you probably know there are like two ways of a classic work breakdown structure. The one we did right now, 1 minute ago, there's the functional work breakdown structure. So we broke down the system to the functions. And this is very useful to estimate the size of a system. Okay, so we understand how big is the system, what is the scope. Another thing here is the activity work breakdown structure. This is what exactly being reflected by the Gantt diagram. When we have all the activities that should be done, their order and dependencies, like, okay, first we're doing this activity, in parallel we can do this one, then it's dependent on next one, next one, and next one. So we see the timeline with the activities mapped on it, and this is the way we can estimate the effort and schedule in the system development. So, but for the current estimation, we need to know only the size of the system because we're estimating the number of test cases to be created. So this is what we're interested in right now. But of course, you can do both. And good test manager or good project manager will always do both things, to define the scope and to define the list of activities mapped to a timeline, to have the complete vision at the beginning of the project to understand how it will go. So let's continue here. And of course, this is like the activity work breakdown structure example. So I didn't want it to put here as the real example because it will take like another like 20, 30 minutes of our time. So just provide you the example of how this activity WBS can look like. So if we do software development, of course, we have different like phases of doing it. We have like scope definition, software requirements analysis, design, blah, 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 etc. And each of those phases consist of different activities, like determining project scope, sponsorship, resources, core resources, etc. Then we have activities during the analysis and design. So we need to create a draft of specification. We have to develop like preliminary budget. We need to review the specifications. We need to incorporate the feedback, etc., etc. So those are lower level requirements that are being conducted within the phase. So this is, we do the same decomposition, but from the activities perspective. And of course, we can map that with a timeline. Of course, you would say, hey, but we are working with Agile. Like, what? We don't need this. Agile is the way of doing the iterations, right? But each iteration can bring some value. And even we have those iterations, we still have the releases. And not all projects have like a release once per sprint, because it's like a huge overhead. There are lots of complex solutions that may have like 5, 7, 10 sprints or even more to develop one release. And this like WBS can be created for the release in the Agile approach. So if we go with like a classic approach, like waterfall, V model, no problem. We can like have these WBS estimation for the entire development project and testing. But for Agile, we can do that same for the release, because it's also a little development project. Okay, so this is how it may like. And you can put this picture on a timeline using the different tools to creating Gantt diagrams. You just put items there, put in proper order, put some dependencies with them, etc. So that's also an easy way to do this job. But what about the digits? What about the numbers? What about the estimation? So, as I said, high-level estimation are based on assumptions and average values, because you need to make an assumption. Okay, so let's have a look here. So we have this amount of test cases. Let's count it. Main page 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And of course, this one, like 25. So 25 positive test cases. Cool, but how many negative test cases do we need to cover this? So we already reviewed the system while we were creating this positive map. And what can we say about the system? Is it complex or no? I would say, I would personally say that it's not complex. It's like very easy, because the one purpose of this website is to provide the way to access certain trainings, webinars, lectures, etc. So it's like an easy website. So I would assume that we would need like 2 negative test cases per 1 positive test case. Am I correct? Who knows? What do you think? Put in comments, what do you think about this? How many negative test cases we would need for per 1 positive case? Maybe 1, maybe 2, maybe 3. How many? Okay, so if you're not, if you're not typing everything in chat, That's because I broke one of the most important laws in estimation. I will talk about this later in detail, but general thing is to not share your estimation with other participants before they vote, because you make an impact on their opinion. And if those people trust you, or those people believe you're an expert in something, they would most likely provide the same estimate as you. And to avoid that, you need to make it anonymous. So in this case, let's go with this. So we need like 2 negative test cases per 1 positive. So we can already calculate the amount of negative test cases. It will be 50 because 25 multiplied by 2, so we have 50. All right, and right now, let's back to this. So this is only one thing about test cases. So we would need to assume several things to make estimations. So like how many time it would take average test case to create, positive or negative? How many time it will take one test case to execute, manual and automated? How many time it will take to make a defect report? How many time it will take to do average rework because of defect or average rework because of a change? So these like basic assumptions we need to do by ourselves. This is what we need to do based on our experience, based on our knowledge, and knowledge of other people that also participate in this estimation. So once we defined those magic numbers, we can easily proceed with estimation by formula. So what do I mean here is, you remember this picture, right? Before from this slide, right? But this is a little bit bigger. So I will provide you the estimation for this project in numbers. So here I have like 1, 2, 3 pages. I have like in these big features, I have more little features, etc. So I came to this. So I have admin page, right? That's right here. I have like accesses, users, others. I have alerts. I have actually mentioned here the big features that have sub features in them. Sorry, and I put small ones in others. So I did it for every of those. Like, okay, for accounts, I have phone, login, and others. For alerts, I have sort by, filter, and others. So I have positive test cases here. I put it like, okay, for admin page, that's a big piece of work. 91 positive test case, 41 for accesses, 32 for users, 11 for others. So this is like a bottom-up estimation. I have some same for alerts account, and I have total 118 positive test cases. So what about negative? I have the same estimation here. Like amount of negative test cases is positive multiplied by 2. So I would need in total 236 test cases negative. And of course, I would also have some corner cases that I need like to specifically manage. Like for example, for phone, I would probably need some way to change my phone, right? In case I lost it or something. So this might be another corner case. So I would say 10% of all negative is the corner cases. So I would assume that, okay, here in others, I have 22 negative test cases, 10% will be 2.2, but I would round up to the highest one. So I put it 3 here, okay? So I do it for all those, and I will have 26 corner cases. So if I put a total, I will have 380 test cases in total to do that piece of work. It doesn't actually mean that it will be like about 400 test cases in test management system. No, I just mean that 380 test cases. So not test cases as document, but cases about testing, test cases. So this is what I will have here. And on average, I would probably estimate 1 engineering hour per 1 test case. Like 1 engineer spent 1 hour to design and create and document some 1 test case, right? Some test case. So if I assume that, taking into account simple solution, simple approach, etc. So I would assume that this admin page having about 300 test cases will take 7.5 engineer weeks. Because why I would say 1 engineer hour per 1 test case, it can be done like for 30 minutes, right? You also need to calculate like resting time or time spent for meetings or time spent for, I know, something else, for coffee, for example, for dinner, for food, but still it will be like 1 engineer hour. I would just assume. If you expect large amount of meetings, if you expect some long and complex test cases to create, you could put like 2 engineer hours per hour or 3 engineer hours per hour per 1 test case, and it's okay. So in total, you'll have here 7.5 engineering weeks for admin page, 1.5 engineering weeks for alerts, and 1/2 of engineer week for account. So in total, you will have 9.5 engineer weeks. And does it look like the evidence-based estimation? Yes, because you already showed the logic. How did you calculate? How did you found those numbers? So of course it's high level because I didn't much care about the details, right? So I just put like a random numbers, say like 1 engineering hour per 1 test case. Okay, in real it might be 1.5 or like 30 minutes, no problem. I just showed the logic. What do I use and like how do I do that? So in general, we can see that it takes 9.5 engineer weeks. So you can do completely the same for this case, right? So following this logic, let's just calculate it. 25 positive test cases plus 50 negative test cases plus 10% of negative plus 5 additional test cases. So we'll have 80 test cases in total. So 80 test cases are needed to cover this website with like estimated 100% coverage. Okay, so 80 test cases, we would assume 1 engineering hour per test case. So it will be 80 hours, 80 engineering hours. So if we estimate 8 hours per 1 day, so 1 person can complete the testing of this website. I mean, test case creation, create all the test cases for just 10 days. So design, create, document, put all the test cases to test management system. I can estimate it for 10 days, like 1.5 weeks. Does it look right to you? How do you think? So we have like 10 days estimation. Of course, it can be done faster, like in 7 days or in 5 days, but still you see the logic on how did they follow this. And this is only like creating test cases. Of course, when you create test case, you usually try to execute it, try to use the system, click it, and you find some defects during the test case creation, and that's completely fine. And you can report those defects with that time, and maybe you would have even testing the system during these 10 days. So you probably find some defects, report them. So eventually, after the completion of test case creation, you may execute each of those test case before right now, because you already created those test cases, and after you complete the test case, you would need to execute it to just check, right? So this is how does it look like. Very fast estimation. You draw the picture. Like, I've spent like 10 minutes on creating this picture, right? I calculated those features for positive, negative, corner cases, and I provided you with an estimate within 15 minutes. So this is pretty good, right? Of course, if it will be like more complex system, it could be like larger tree, bigger numbers, etc. So I would spend maybe 1 hour. Still good, right? Maybe 2 hours, but still good. So I can estimate it. It's bad I can't show you the real example, but I have like these three very large, like thousands of those features. And what is interesting that it took like maybe 1.5 hours to draw them, and maybe like 30 minutes to calculate the numbers. Still very fast. So this kind of estimation, high-level estimation, is a certain way how to do the proper high-level estimation. Okay, so do you have any questions so far? Okay, I see there. So is there an estimation? Is there an assumption that creation of each ticket will take some amount of time, be converged to some average, when there is buggy feature and numbers requirements on branches, which you will need to derive from someone? Well, okay, yeah. So here's the thing. What's about the average? Later on, I will show you the ways how to define this average. But in general, when you're picking some average one, it means that one test case, one activity can take less time than average, but there is another one that can take more time than average. So this goes to a balance. You cannot know how many features will take more of average or less of average, but eventually you need to make some kind of assumption. And of course, there could be like buggy feature, something not obvious, and you need to get from somebody else some kind of estimation. You can do it in this way. Estimate everything except this one, and contact the person, somebody who can tell you the estimation, and ask like, how do you think, how many it will take? And put this number to your picture. You know, it won't spoil much your bigger picture, because I guess this piece could be like 10 times smaller or 20 times smaller than your entire picture. And this like a little noise, if this person can do wrong estimation, no problem. It wouldn't change the picture that much, to spoil your estimation. So it's completely not a problem. Just contact the person and say, hey, how do you think? How long it would take? If person say, I don't know, you say, okay, minutes, days, hours, weeks. Person say, okay, days. How many days? 5, 10, 15, 1, 2, maybe 2 days. See, when you're asking not just open question, how many, you just provide like the list of options to answer. Usually people provide better estimation. This comes up from the well-known playing poker, right? When you have certain cards that you can take, it's much easier for you to get it. So you just contact the person and say, okay, hey, how many days? 1, 2, 5, 10. Person, well, maybe 2, maybe 3. Okay, you think it most likely will be 2 or 3? To just narrow down the estimation. Say, well, probably, I guess 3. Here you go. You have this estimation. Even if person said, I don't know. Well, I don't know. It's a hard question to answer. Blah blah blah. So you still got your number. You just put in your picture, and that's fine. So this is the way it works. So what about the techniques for low level estimation? Let's have a look. So low level estimation is something you will need to create in details. And in most of cases, it shouldn't be one person estimation. So low level estimation usually are created in team with certain participants with different opinions on how to do this. So this low level estimation are needed to be performed with multiple people, multiple representatives with different background, different opinion, and using some kind of a process to make it efficient. Because always you probably know that if something have the well-defined process, it goes smoothly and kind of effective. But if something is chaotic driven, well, it's usually not effective. So we need a process. We need some kind of a technique approaches to follow. And this is why we need, to do this estimation. So here's the thing. I would like to present you the Wideband Delphi approach. You maybe heard about this before on some kind of, websites, books, whatever. Just like a short description on where it came from. So the first approach was called Delphi Approach or Oracle Approach. So it was all about to do some kind of random guesses from different people. Then there was like an average number being put, and in this way, like you have some kind of an estimation which was still kind of rough and didn't provide a good accuracy. So Wideband Delphi, it's like a version 2 of it. So this is like a completely comparably new approach that gives you kind of a process how to do the estimation. So basically you have the some collective wisdom from other team members that you use for your estimation. And also, of course, this is like a good way to say, hey, this estimation was done by team, not by me. No, you cannot blame me because this is like a team estimation. I'm just kidding, sorry. So because people sometimes are usually afraid to do estimation because they can be blamed if those estimations are poor, right? So you need to know that anonymity is the good way of doing estimation. I'll talk about this a little bit later. So let's take a look at the process. The first phase is choose estimation team. You have to gather the right people for the estimation. you will have a kickoff meeting explaining what's happening and what we're going to do with this. Next phase is the individual preparation, a good way to perform personal estimation on your workplace, on your home, whatever. You just don't need to do that online in meeting, waiting for everybody to complete. That's eats a lot of time. And also there is an estimation meeting where we can get together, compare our estimation, etc. And of course, evaluation. So let's go into some details on this. First thing is how to choose the estimation team properly. So how to do it in right way. I've been heard like lots of cases when estimation or test cases review or requirements review or lots of some kind of activities called useless because wrong people were invited. Let's say you're getting the people and say, hey, help me to do the estimation. And one person says, nah, I don't believe in this. That's sounds like, weird to me. I don't believe this is like a good activity. Let me do my work, my real work. Why should I spend my time on this useless meeting when I can just get and start coding? You probably heard that, right? Because I do hear this very often. And what is important to know that you should avoid people who don't believe in the activity you invited them to. Inviting the entire team to do the estimation is also wrong approach. Well, if it will be another training on the meetings, you just probably just try to calculate how many time you spend on meetings. And especially if you call just one meeting for 1 hour, but for the entire team, you don't spend 1 hour. You spend like 10 engineering hours for this meeting because there are lots of people to attend this. But what if you can arrange this meeting by just 3 people because you need only opinions from those 3 people? You don't need other actually to listen, right? You can make an email and tell them after, right? So you can spend 3 engineer hours instead of 10. This is like a short, short overview of a training about the meetings that can potentially be done. But anyway, this is important thing. Pick people with a different background, expertise, and opinions, because they will bring right question during the estimation. There is the question in chat. So should it be testers from the same project? Usually, if you have enough people from your projects, to participate, of course, you can only use them. But if you feel you don't have enough of people from your project, you can invite others or at least one from similar project if you have this option, right? So in this case, you can of course invite somebody from their parties, but it's completely not a problem to hire to invite somebody from different project or even from different company. This also looks good, but very important to know if this is the right people, if this is the right person. So also one more point is that small team estimation session is better than big one because you will need to manage this thing, right? You will need to moderate it. You will need to conduct it. The more people you have on estimation, the worse, because if you have 10 people to do estimation, that's a lot. So if you have 1 or 2, that's too small. So 3, 4 people for the estimation session is like perfect number. Up to 5, I would say that's okay. If you have more than 5, then it's like a complex estimation. So I would say small number of estimation team is good. So put several people with a different opinions, different expertise, and put it to your estimation session. Because if you put, let's say, the example, so imagine you have the test automation team of 7 engineers, and you have like 4 senior people there that can be invited to this estimation session. And for example, you have like 3 people that are always thinking the same, that always agree with each other, and there is another guy who always say, well, you're not right, I have another way to do this. So better to invite this guy and one of those 3 persons, because they have different opinions, and this is very good for the estimation, for the review, for the planning, etc. Because if you put like several people with the same opinions, they will give you just same opinion, same answer, and it's not too smart to bring all the team. So those people you should bring in, and you should avoid those who don't understand the object to be estimated. Like you probably know the jokes on like doing the poker planning in Scrum teams, which consists like say like from like 3 developers, 3 QA, and 1 biz analyst, right? And you just, when you're doing estimation about the testing tasks, developers are saying like, what I'm doing here, I don't understand what they're talking about. And the same when QAs participated in the development estimation, they just put in random numbers, and thus they bring noise to the estimation. They make it very blurry, because only those people who understand the objects, the object, activity, etc., that is under the estimation, only those can be invited for this session. And also, as I said before, those people who do believe they should stop doing this crap and come back for the real job, they also shouldn't be invited, because they will sabotage it. That's for sure. So for like simple points on how to get the estimation team members. So once you have it, you go to the kickoff meeting, and on the kickoff meeting, you also should do several things. First one is to make sure everybody understands the estimation approach and the process we go with. This is important because once people know what's going on and what will be in future, they will have their time to prepare for it and do what they're required to do. Second thing is make sure everybody understands the estimation units and different constraints, like the level of detail. Let's say, should they put the estimation units in days, or it should be like 1, 2, 3, or they should like put accurate estimation, like two digits after point, like let's say 1.64, etc. So they should be given certain estimation units and the accuracy and different constraints about the estimation, how it should be done. So like, for example, you should always round up to the higher value. So if you receive 2.4, you should round up to 3. Okay. So third thing here is to make sure everybody understands the estimation scope and boundaries. So we estimate from here to here, not more. And last thing is to prepare the estimation template that we need to fill during the individual preparation. And this template is the reflection of person opinion. Why do we need a template? Look at here. So this is like an example of the template. So we have like here who does the estimation, estimation units, engineer hours. Okay. They have some list of tasks to estimate 1, 2, 3, 4, 5. And people put the initial estimate here, 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 and here. So this is like a homework for every person participating in estimation. And why it's important to do that, let's say it offline, because each of those people can think more, can read some documents, can refresh own memories, to do the proper estimate. Because if you do it online with everybody on the meeting, somebody can think very fast. Somebody may have a hangover and just think very slowly, It might be. So some person can do it fast, some person can do it slow, some person can may need to remember something, can need to read some documents, and everybody wouldn't wait for this person. So this is why it's better to do it, like at home or in off meeting time. So this is why we need this estimation. And one good thing here is that this should be anonymous for the estimation team members. Only the estimation lead might know the names of those people. So basically, this works this way. So here you put this template. Okay. Then everybody should do the individual preparation. So they usually, sitting on their workplace or at home, they grab a cup of coffee, they're relaxed. By the way, we probably need to go to grab on coffee, right? So I guess let's go just in a couple of minutes when we finish this slide, right? So we'll have some rest. So yes, once every person come to this template, it's very, very good way to save this common time in meetings. There is no rush for people, and you have a time to think, a time to consider, maybe a time to change your mind after you estimate other tasks, and every estimation team member fills this template independently. And everybody should know that this will be done anonymous. So you won't be blamed for your estimation, because there are lots of political things under many project activities, and people usually afraid of talking, of doing some estimation, of reviewing something, or asking like rough questions. So this is a good way to do it. And also enough time for everybody to prepare the questions and points to discuss. Like, for example, to change the mind of other people on estimation meeting if needed. So during this individual preparation, people are filling those templates and coming for the estimation meeting. So, okay, now it's time for a break. Okay, so let's put like, I don't know, 5 minutes will be enough, right? So I will put here start of the break, 5-minute duration. I'll just put it to the chat so you can see it here. And let's come out, get some little bit rest, get some coffee, tea, and come back in 5 minutes. All right. Cool. So let's have a break. Okay, hope you're getting rest, at least a little. Okay. So the estimation meeting. So right now, assume that everybody from the estimation team is ready for the reviewing their votes, their estimation numbers, and everybody here giving those templates or share them with the estimation leader, with the person who moderates the meeting, who leads it. So everybody share the estimate with the person, and those votes are marked on the line to see what people are voting about. So all participants right now doesn't know what numbers everybody showed, but sees the numbers that they have. So just look at this. So this is the estimation plot for the round one. So though there are 5 people, they do vote, and they see, okay, I have vote like 30. 37, maybe 42, 58, and 78. So at this point, nobody knows who's been voting about this. And right now is the biggest goal to shrink those votes to some range that can be acceptable. So if we come back here to the slide and see that after that, each team member reviewing the estimate and raising some questions, identifying some assumptions, and during this period, the task estimates are not disclosed. Still, nobody knows about the estimation. So right now, you see, okay, this range of numbers, and you can say that your opinion about the minimum and maximum estimation applicable on this picture. So in this case, excuse me. Yes, so in this case, every person says what he or she thinks regarding the minimum and maximum estimations here on this picture. Like, for example, I'm saying, I don't think like the estimation of 78 is good because it's too high. I would say like maybe around 60 is good, or around like 45 is good because of blah, 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 blah. Like somebody may say, okay, we did this task 2 releases ago and it took this size. So I do believe it will take not less than that. And there was like estimate 60. So I would say maybe 60 or 65. Somebody will also say, hey, do you remember? We have half of this work already done, completed. So it will get less. And everybody will say eventually like, oh yeah, you're right. Wow. Yeah, I didn't remember that. So yeah, we need to change our estimations, right? But at this point, still nobody knows who done which estimation. So in this case, team discusses any doubt problem and then revisit list and assumptions and then repeat again. So after seeing this round one, everybody put in the template here, change one right here. So they change their opinion if they did. If they not, they just put the same digit here. So in this point, we can put changes. Like one person say, okay, on task one, I changed the opinion. It should be less by 2 points. On task two, I remain the same. Should be same, 0, no changes. Task 3 +1, task 4 -4, task 5 +2. This is like my current changes that I have. So in this case, it's usually the same. Usually after each round, those votes are shrinking together. Very important to define the good enough shrink range. So in this case, it's still like between, I would say, 45 to 82. So from 45 to 82, still there is a large range, I guess, like 35 points, a lot of them. So we still need another round to shrink it. So same round, why do you think it's not the smallest amount and not the highest amount? So people, again, discussed more and more, and eventually we go to round 3, 4, etc., until we get some kind of consensus. We shouldn't get all the same estimates for the entire team like it's done playing poker, because here's the thing, it may take a while for people to get agreed, and at some point people say, okay, whatever, if you want 40, here you go, no problem. We shouldn't allow this. People should not get tired of it, and this is why we need a good mediator to lead this estimation and not conduct too many rounds. We shouldn't we should at least give some range. So for example, we can assume that 20 points is the acceptable range. If we were saying about from 1 to 100, 20 points is just like 20%, no problem. So we can put to this range. And when we get it, like range from, let's say like from 62 to like 78, we say, okay, there is 16-point difference. So we can take average, which will be like, how many? 8. So it will be like 70. 70 points is the estimate of a team. Okay, let's go. Let's take it. So this is how it goes. What is more important about this is to have the history of the estimation. So if you have it, back it up somewhere, these can be used to learn on your mistakes. For example, after project is complete, after release is delivered, you can still have some retrospective and say, hey, we were estimating this and we totally, hooked up the estimation, right? So we just cannot go with it. We need to understand why. So we go back to the archive, we take back those estimations and see own estimations lists and think why didn't we talk about that? Why didn't we mention that? Why did we put this number or this number? Because if you don't have these templates, you can come to retrospect and say, well, I don't remember. I don't know why. Who did that? I didn't that. I didn't put that estimation. I was voting for, I don't know, for 20. So see, if you have the history, you can come back and learn. If you don't have it, you will forget it. So this is a good approach on having not only team estimation, but the evidence-based estimation. So you have a team of people, group of people who had own estimation, and you can always analyze how the opinions are shrinking, so you can see who's been changing at what amount. And of course, after the estimation is being defined, those numbers can be shared to all team members, so everybody will know what were the votes of each other. But it's very dependent on the team. If you want, you don't open it to everybody, so it's not a problem. Anyway, this is how it goes. Any questions so far? You doing good there? Okay, how much time is between the rounds? So those rounds are usually not time limited. The reason is to shrink to acceptable range, right? So if moderator do believe the team already have some concerns, points to change their minds, say, okay, we go next round. If still moderators see that everybody stands on own estimate, then still people can talk. When moderators see that there is already some people who say, okay, well, I didn't know that. That's a good point to know. And they're ready to change their mind. It comes back here. Of course, there might be one person who may be voting totally off the picture. Like, for example, voting for 20, while others voting for like 80. In these cases, this one voice, if not agreed, it may be just ignored. But still, it's very important. Then in such cases, the names of the values should not be disclosed. Just leave it anonymous as is. So in this case, people, they could could not be afraid of doing some estimations they believe they are right. So this is the way how it can be solved. And let's talk about another technique that allows to estimate in detail using formula-based approach. So while we have here Wideband Delphi, the process of the estimation, right? We still need to know how to estimate one element in our, let's say, like homework, right? Or at least how to estimate properly one item. So this is what three-point estimation is all about. Here's the thing. Usually when you're talking about three-point estimation, people say, okay, yeah, I know that. It's like most optimistic, most pessimistic, most realistic, three values, put it together and just divide by 3 and you get a number. That's not completely true because there are too much math under this. Actually, I put some graphs on next slides. Those who love graphs, who loves math, can take a look. I will explain a little bit, but still, I don't want to talk about math here. I just would like to say that under this three-point estimation, that's a solid, huge basis of math, of probability predictions, and different probability laws. So it's all about normal Gaussian distribution, etc. But the good thing we should know here is that there is the formula that can help you to provide some estimation, but the magic in three-point estimation is not in this value that can you calculate. The magic is in the standard deviation. So once you're saying, okay, the estimate is 10 plus minus 2. So plus minus 2 is the standard deviation. Is the something that can deviate from the middle number to plus or minus. So, and this standard deviation can be calculated with formula. So this is not like when you say, okay, we estimate, let's say like 10 days plus 25%. Why 25%? Because, well, I always pick 25% to any task, to any project, any team, any constraints. This is like very rough estimate, is to put the like similar numbers each time. Better to calculate it. So there are two ways of doing it. The first one is using the normal distribution. There is a technique called PERT, right? You probably heard that before. I'll talk about this later a little bit. And the triangular. So the, we'll say, regular one, when people say, okay, three-point estimation, then we have optimistic, most likely, and least likely, and divided by 3. So they give a little bit different results. So in normal distribution, PERT, there is states clearly that most likely estimate M has a weight 4 times bigger than most optimistic and least optimistic, the pessimistic one. So it says that those like extreme points don't have equal value of an average number. Like in triangular, when you say, oh, they are all equal, So this is the case, and this is why during calculation of a standard deviation, you just have a simple formula. You take least likely estimate minus most optimistic and divided by 6, because you have 6 pieces where you have 4 pieces of a most likely estimate. In triangular, that's kind of a complex. That's a square root of this equation. So it may get hard, but let's have a look at the example. Oh, and one more point. Of course, most likely estimate should not always lay between optimistic and pessimistic estimate. Why, you say? Because let's imagine the thing. So we talk like, okay, most optimistically, we can finish the testing in 10 days, but we won't finish the testing in 10 days. To finish testing in 10 days, we need to have, very huge luck here, 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 and here. So 10 is the most optimistic. It cannot be faster than 10. 10 is like most optimistic. Also, we have least optimistic, like pessimistic, say, well, probably there will be defects. Well, in the worst case, there will be like this, and it will be like 20 days. But I would say that the most likely estimate is even worse, because we don't have this, we don't have this, we have problem here, we have those 3 people on a sick leave, etc. So the most likely estimate will be 25 days. So that's why most likely estimate can not always lay between pessimistic and optimistic. Usually it does, but not always. We just remember that. So standard deviation, what is all about? A little math here. So there is a theory of a probability that says that there is always a probability of a random number put in some place on this curve. So here's the point. If you take marks of all students on one course, you will find much more average marks than those extremes. So for example, if you take like random number set and try to sort it out in this way, taking into account the the value of a number and the position amount of this number, you will have this curve. For example, if you have all those marks, the marks with, let's say, like 3 will be much more than 1, but less than 4. 4 could be at some point, but how to explain by hands, I don't know. So so people who have average marks, they'll have the biggest amount. People who have like bad or very good marks, they'll have less amount. And so this says that there is a standard deviation from a middle value that gives you certain vision regarding how the actual number can differentiate from the estimate. So one standard deviation, this is like also calculated formula. So confidence level is like the confidence that this standard deviate amount will be enough for your real value. So for example, if you put your estimate plus minus 1 standard deviation, it will be like 68% probability that real number will fall into this range. If there will be 1.645 of standard deviation, approximately 90% probability that real number will fall into this range. So normally people use 95% confidence level, which means you should always take twice standard deviation used for many projects and task estimates. I do it in this way. like always do 2 standard deviation. So let's have a look at an example. How does it work? Enough math. So here's the formula, which we already saw, right? And let's assume that the most optimistic value is 5 days, okay? Most likely will be 8, and most pessimistic will be 15. So in this case, we're doing calculations using normal distribution, PERT, and what we get here, we get 8.8. What we do is just we take 5 plus 16, what? No, I guess it's a mistake. 5 plus 15 and 4 times the average value. So we get 8.8 here, and now we calculate the standard deviation. It will be 1.8, which means that the total answer will be 8.8 plus minus 2 standard deviation. So 8.8 plus minus 3.6. So it will be the range from 5.2 to 12.4. So from here to here. And the real value will definitely, with 95% probability, will fall into this range. See, this range is shorter than same one in triangular. Why? Because here is the answer why. So that is also a little more math here. It's about that this curve for PERT, you know, it's shorter, and triangular is wider. That's because of some laws that lies behind. I won't go this deep, but just saying that triangular, it's like safer, but not that precise as normal distribution, which comes to the general like rule of thumb is, if you need very precise estimation and you have the most data possible to do the estimation, you have to use PERT. If you have very blurry data, like lots of things unknown, uncertain, you should use triangular one. Because if you use noise data on PERT, then you will fall into this high curve, but with a small width, and the standard deviation will be crazy. So rule of thumb, if you have many data, if you have almost everything you need in a good quality, in a good precise, you use PERT. If you don't know everything, don't have data, have incomplete, noisy, uncertain data, use triangular approach. So this is how it works. And in this case, you can always pick this formula and say, okay, this is the way we calculated, according to the formula, certain estimations. You know, it's very hard to fight with the estimations that are done by formula, by process, by well-known techniques. In this case, it's very easy to defend, because if you're doing estimation like by a wild guess, and somebody said, hey, we need to do this tomorrow, like somebody mentioned already on inputs, you would say, no, it's impossible. Here, take a look. Here are formulas, approaches. We calculated. It's impossible to do it tomorrow. So we'll do it in this time. If you really want to do it tomorrow, we can try, but we can't promise you. And more that, we cannot take responsibility of the quality of the completed work. If you agree with this, great. So here's the thing. These formulas, these approaches, these techniques defends your estimates, because not only your expert opinion here is in place, but some math, some processes, and large experience and history of this technique into domain. Because those like Wideband Delphi, for example, is being created in somewhere in 1970s. 1970s, like 50 years ago. What is more interesting, that playing poker, you probably saw some, some common between Wideband Delphi and playing poker, right? Something common is in there. But playing poker is being invented, put it this way, in 2002. So 30 years after Wideband Delphi is being created. 3-point estimation is something with the dates, I don't remember, 1975 or 1980, but somewhere there. So still long time in industry. And like it's a proven method of doing proper things. So this is the way it works. Let's have a look at playing poker. This is another way of doing estimations, right? So we should also know how to do it in proper way. So we'll know that playing poker is played with a deck of cards, right? So usually it's Fibonacci sequence. But here's the thing. Many people do ask, hey, I saw the poker playing cards with a regular sequence of numbers, 1, 2, 3, 4, 5, 6, 7, 8, etc. Why do we need those Fibonacci sequence? So the good answer is that the bigger the number, the bigger the difference between previous and next one. Why? Because you have to look more carefully about this estimation. So Fibonacci sequence is the best to use during poker playing. Also, why cards? Because if person see numbers, it's easy to think, hey, it will be 3 or 5, or maybe it's 2. So it's easier to evaluate each of those numbers and see which one is the best fit. The another problem is about the understanding of a story point. So how to understand the story point? Story point is something, is the complexity that is related to the time, scope, effort, and risks associated with an object, right? So many different factors that you are usually not able to calculate, but you can imagine. So what you do is just saying like, okay, so complexity is something you can like predict. For example, if I will ask everybody of you, estimate how many time do you need to cook lasagna? How many time would it take? So if you are doing it every day, you will say, maybe, I don't know, 45 minutes, maybe less. Some will say, oh no, I need to read, I need to get a recipe, I need to get everything. Well, I don't know, maybe 2 hours. Somebody will say, what lasagna, what is it? 5 hours. See, so answers will be completely different because it's like, hard to understand. But if you asked about the complexity, is it hard to make lasagna? You will say, Well, it's not easy, but it's also not hard because, well, if I get a recipe, there is not much magic there. Just, everything is comparably simple. It's not that simple like an eggs and bacon, but still not that hard as like a birthday cake, right? Or I don't know. So still the complexity can be comparable. So if you know the complexity of the eggs and bacon, let's say it's 1. So you can compare how many times lasagna is harder to make from bacon and eggs, because bacon and eggs, you have to get it fried, right? To the certain temperature, to the certain extent of time. Same thing with lasagna, but lasagna is just, you put in oven for the certain temperature and amount of time. It's easy, right? So from this perspective, it's similar. Right, for lasagna, it requires more components. Okay, harder from this point. And these components must be placed like layer by layer, etc., etc. So kind of complexity here. So I would say, like, for example, 5 story points for lasagna and 1 story points from chicken egg. So see, it's much easier to compare the complexities of 2 different things. Even if you never done it before, you tasted it. So you know how does it look, and you know what are the approximate components. So you probably can assume how harder is it. And by meaning the complexity, you mean all these constraints. Is it long? Is it hard? Is it risky? Everything in there. So once you have defined 1 story points correctly in your team, like the one easiest task is 1 story point, it's much easier to estimate because you usually compare this task with this one. Even if you feel that you feel it's hard to compare simplest task with your one, you can always pick another task which is already estimated, right? And compare with it, also simple. So in this case, you see that you can put right numbers on right places, and you can negotiate. You can also present your opinion during this playing poker. So you say, I do believe that this is simple. Like, even we can make it simple by doing some preparations for it, right? We can prepare meat beforehand, etc. So we can simplify this in future if we have like similar tasks in future. So this is what playing poker is about. But playing poker doesn't solve one problem, the anonymity, because in playing poker, you always should open up cards at the end, and people see who usually is voting all about. There is a comment, I guess, in chat. So doesn't feel much in numbers, it bring in fear of bigger numbers. So people probably won't underestimate in case of complex tasks. Feels like it forces distinct between items in the middle, but scares away from the 3, 4, etc. numbers. Yes. So here's the thing. Yes, it scares you from bigger numbers, but the problem is if you do believe that this task is very big, it's like huge, you can easily take, well, it's maybe 34 or maybe 100. Hey, look, 100 is 3 times bigger than 34. Why you're saying 34 or 100? Because this is like a sign, this is like the focus point, like a trigger for the Scrum Master. Scrum Master says, oh, wow, okay, this story must be decomposed to the smaller ones, because right now I hear it that somebody says, okay, it's 34 or 100, I don't know. See, so this is all about, like, until people can estimate the user story between, like, say, like classic numbers from 1 to 13, let's say, not a problem. this story is good and okay. If people start to arguing between 21, 34, 100, it means that this story is huge and it should be decomposed. So this is the reason. Usually people afraid of big numbers, right? But if a story is obviously huge, then saying like, okay, 21, 34 at least, which says story is huge and should be decomposed. So this is like how it works. Do you have any questions so far on this topic? If you do, please leave them in the chat. Okay, so what is so important about estimations? So what are the main reasons and rules on how to make them properly? So first thing is, as I said many times before, anonymity. So it's very important then people who vote, their identities are not associated with the values before the completion of the effort. Sometimes even after, it's not disclosed. Why? Because there are like many different effects that are big problems in estimation. Like for example, the influence of people to you. Like if you respect some person, it's very hard for you emotionally to put the different estimate from this person. Like say you have like one team member who is like the awesome specialist, like the expert, the guru of all this thing. And this person says, that's probably will be 21 story point. And you think it's like 13, but emotionally, it's very hard for you to say less number than this person said. Why? Because, well, who am I to argue with such expert? This is why it's very hard for some people to behave properly in these cases. Also, some people may be very, have like high charisma and can have a proper convince other to vote for certain number. And people will do that because of a crowd effect, for example, like an effect of a train wagon, So same thing. People who are working together, who are, who know each other properly, then can obviously pick same number as their friend did. So to prevent this, you need to break the association between identity and the value, at least until the final report. To enable this like proper estimation, because if you don't know who vote for what number, you're free to use any estimation you believe. Second thing is the dedication. Again, if somebody doesn't believe in the need of estimation and thinks it's a waste of time, those should not participate in these sessions, because they will sabotage it. They will pick random numbers. And just imagine if you have like 3 people doing like a proper work, and there are 2 people who are, think to complete this faster and come back to real work. They will put random numbers. So if you have 3 sets of good numbers and 2 sets of bad numbers, you will have like chaos, really. You have like unrealistic numbers, unrealistic standard deviation. You cannot calculate everything. So those people you should be afraid of. And people who don't understand how to do this estimation, who don't understand how the task that are estimated should be performed, should be executed. They should not participate in estimation session because they will pick random number. Of course, playing poker has special card, right? Saying with a sign, with a question sign on, right? Like, I don't know. But see, here is another point. Some people, well, many people doesn't want to look like a stupid, and they afraid to put this question mark because somebody may think that I don't know about this task, but other know. So I may look like stupid. No. So people in this case doesn't use this often and just put random number. Just put like average number applicable for this case. Like, for example, like if the previous result was like 13, people will say, okay, I put 8, right? It's similar, so no problem. You should avoid these people too. And remember one more thing. Estimation in general is the approximation. This is not a magic number. That is done when input data is noisy or incomplete or uncertain. And estimation doesn't provide you certain numbers to follow. It gives you only the range, like from here to here. So eventually you will fall in this range at some point. And if you practice estimations more and more, you'll get to a point when this range comes shorter and shorter, because you will learn how to do this estimation. You would learn yourself how do you think while doing estimation. When you're learning on your mistakes, you would think, okay, usually I'm not thinking about this one, but I should think about this one. So next time I will think about this. And this is important. And one, sorry, I guess. Yeah, sorry. I have shuffled the slides a little bit. There are a couple notes in chat. So, okay. Doesn't complexity estimate becomes relative to some average skill expertise? Then we'll have task for 3 days of average engineers, but we'll have one junior and one senior pro. And for example, junior will do it like forever, while senior can do it while sipping his morning coffee. Correct. But look, you're doing this poker planning within an agile team of engineers, while nobody knows who will be doing this task, right? So it goes with the same thing. You provide the average estimate. Of course, if this average task will be performed by junior, it will take longer, but second average task will be completed by senior. It will be faster. So senior will finish faster and take another one, or help junior to complete his or her one. So this is same deviation. So we're talking about average estimate. And this average estimate in one case can be deviated to minus, but in second one to plus, and you will have a balance in the end. Because if you estimate tasks in hours, you will definitely fit into this problem. Junior won't just be able to complete this task within these hours, right? So complexity removes this connection between the seniority level and the time to complete the task. It just moves to the case where you have average. And using average, you can always go to different ways. Okay, hope I answered your questions, right? Good. So the last topic I would like to discuss today is how to estimate the return on investment, right? Because you remember first slide, we can estimate scope now, we can estimate budget, sure, why not? Days or dollars, same, right? We can estimate time, scope, budget, but we don't know how to estimate return on investment yet, right? We don't know. We can't answer one question right now. And this question is about, hey, do you think it's worth to try to move to this new automation testing framework or not, or leave with an old one? Or should we do this improvement? Will it worth? How can we estimate the potential return on investment brought by some improvement initiative or some tool or some new framework? Because this is also very important for the senior testing quality specialist. This is also very important. So that's why let's talk about the return on investment estimations, how to do it properly. So now I want to warn you that return on investment estimation is more rough than we saw with other dimensions right now, because business value may come from very different sides, not only from terms of money or let's say features. It may come from reputation side, right? It may come from some respect from some vendors, some clients, etc. So return on investment is something that cannot be reflected on paper on full size, but still we can estimate something. Let's have a look. So what is here on this chart? So on the vertical line, it's the amount of effort invested or benefit received. So these just the units, 1, 2, 3, 4, 5, 6, just the units, nothing more. And horizontal is a timeline. So let's imagine, well, always good example is about adopting some new tool or a framework, right? So to adopt a new tool, we need to, or a framework, we need to, go to market and check what is there. We can always evaluate some vendors. We can always come to different cases. We need a time probably to get a license and money to buy it. We'll probably need a time to install it, to transfer all, old artifacts, documents, tests, whatever, from old sources to the new one, teach all people to use it, learn the best way how to use it, and at some point, at some day, we'll get profit. Profit can be reflected in, of course, time, scope, and budget. So what is here? Look at this chart on the left side. So just follow my cursor. So we start to investing in a new tool, and it takes usually gradually. So we pay more and more time, more and more effort each month until we have it fixed and start bringing some profit. So some profit comes to play when this curve goes up, because as we gain some profit, it covers some expenses, some investment, right? So this is why we go up, 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 up. At some point, we go to the zero here. So at this point, all our investments are covered by profit. So, but which is important thing, this is not the point where we completely starting to receive pure profit, because the area of this shape is S1. This is amount of effort already invested, and this shape should be covered by some profit, so once we have all our investment covered by profit, we eventually start gaining pure profit. So we are very interested in this point on the border of these pink and green sections. So this area S2 should be equal to S1. And once it's there, we start to gain pure profit. So you see the in this case, the benefit start to grow very fast. Like we passed 3 units per just 1 month. Like, cool. What if we get it slower? If we get it slower, then this figure should be bigger, right? Longer here, and took more time to get to this 0 point. So that's why it's very important to calculate this 0 point, after which we receive pure profit. If we're planning some migration, we're planning to purchase some tool, we're planning to do some like global improvement, we always should calculate and estimate return on investment. Here is why. You probably know that some investments eventually they give more problems than they solved, right? So this is like the ideal case when we did some improvement, when we did some change, we bought some tool, whatever, and we have like pure profit. But what about maintenance? So we paid some initial costs, right? And after that, we're done. But what if we have some ongoing maintenance costs defined, and we should spend them too? Look at the next picture. So if we have the this ongoing maintenance, see it's a blue line here. This ongoing maintenance can be like stable, can go in one level. What is maintenance? Maintenance is the time required to back up some old stuff, or do some cleaning within the tool, for example, or for example, migrate, install the server updates, whatever. This is all the maintenance. Or we need to adapt the tool to the new process that is being defined. So in this case, we need to modify the tool. We need to modify the way it works. So in this case, we need to also count these maintenance efforts. So in this case, of course, this shape will be larger, because when we are still going to the 0 point, we're still paying some effort for the maintenance. So that's why this shape could take longer. But in this case, we'll still get the pure profit, but paying some % of it for the maintenance. Still not ideal, but its real picture is it's pure profit, and it's completely okay to calculate maintenance costs and take them into account. But here's the one more picture that shows you the bad thing that usually happens is when maintenance getting higher than profits. In this case, you start to lose your money, lose your time, resources for that. Here's the example on how it can be done. Like, for example, like there is a project that is looking for a special automation test framework. And they say, we have many smart engineers. We have like a cool people here. Let's write the automation framework by ourselves. We don't need open source, and we don't want to spend money on some proprietary framework. So we'll write it by our own. Okay, cool. Let's do this. So rewrite this framework. This framework usually evaluates through the evolution process, because product does own evolution and framework tries to adapt it. But framework is another product to create. It requires lots of testing effort. It will have lots of defects inside, etc. So at some point, it can grow up to a monster that will be everybody depending on this monster. All our automation works on this framework. And we know that, for example, we are paying right now, like saying like half of automation engineer capacity per sprint to maintain this framework, because we got the failed tests and we don't know if it's because of a product failure or because of a bug in the framework, right? And we pay lots of effort, maintenance effort, every sprint. And we know this is higher than our profit from this automation, but we cannot stop using it because we all depend on it. This is the only place where we have our automation. And to move out our automation will cost us, like a cosmic amount of dollars, right? So to avoid that, we need to calculate this return on investment. We need to think, how many time do we need to invest in it? How many time do we need to invest in certain activities? And how many time do we need to, to get it run? And what benefit will we get? So here's the example on what costs usually required to adopt a new tool, framework, tool, whatever. So this is like an example on what costs should be calculated, what costs should be estimated. So once we comes to this game, first thing we do is the evaluation of a market. We define some requirements for the tool or for the framework. Then we observe the market. If there is any tools, frameworks that are fitting to our needs, cover our requirements. If there are multiple of them, so we have to evaluate the vendors who providing these tools. It can be open source, but it should be the community which supports it, and etc. So we should evaluate the stability of a vendor or the stability of a community who works on this, who fix the defects, who develop new features, etc. And also we have to spend some time, some effort for the proof of concept. This is the one piece of costs. Also, those are training needs that are required for the people to work with this tool or framework. So there are certain technologies that are related to the tool. For example, if we buy some tool that use artificial intelligence and machine learning, for example, for the prediction of the test priorities based on something, we at least should know how this AI ML stuff working, right? So we need a training. Maybe some people knows it, but some may not. So it's certain amount of time required to train them, and of course certain amount of money to arrange some trainings, or even to make to provide these trainings to the colleagues. The other side is the training on how to use the tool, right? Because sometimes we don't think about this and say, well, I would not read the documentation. I will just put in the tool and figure it out. And usually it takes much more time than person could take the documentation, read it, and understand. Or better, just to have a training, but somebody who already knows how to use this tool, how to use this tool in an effective way. So these costs also should be calculated. And third piece is the license and maintenance requirements. We need to understand what are the license fees, if they are applicable. We need to know what will be the infrastructure costs, hardware or cloud. We can select here because, well, if we're like buying a tool for the project that is estimated to last like years, then maybe we can buy hardware, but we need to cover the maintenance effort. We cannot estimate it, so maybe we just pay fixed price for the cloud usage to the cloud vendor, and we have it all there with a zero maintenance. But still, this maintenance will be because tool must be reconfigured, etc. So yes, we need to pick which way we go, hardware, cloud, and estimate. Sorry, and estimate the effort to be paid here. Then some costs should be paid for the initial configuration, because this is an engineering time to configure it right, to read the configuration documentation, or even to order a specialist from the company, from the vendor, who will come up and configure it in the right way. Anyway, it's still the cost to be paid. So there is usually large effort for the artifacts migration. If we need to migrate our test cases, some documents, some schemes, models, mocks, whatever, from one tool to another, it still takes time. We need to estimate that too. And the last one here on the list is the ongoing maintenance efforts, like how many time in average we will need to pay for maintenance, for ongoing. And once we have all these costs, the second thing we need to know is, what is the benefit? What is the benefit from this tool? How many time or money would it save to us? Once we define that, we can compare. Sorry, my neck is being hurt a little bit. So in this case, we need to compare the investment and the return on investment. So we see what benefit we can make. And which is interesting, we should take into account the duration of a project, because, well, if it takes like saying 10 months to come to the 0 point, we'll get the benefit and only partial benefit from the last 2 months, and probably won't worth this improvement, because we can, we can eventually miss to some estimation, and we can even lose. So that's why some projects are not needed to cover with automation, because it can be tested cheaper with like manually. Well, and that's another reason, like answering the question, why do we need manual keys? Because of this, because it's cheaper and faster. At some point, if this is like a long-living project, of course, we need to bring up automation because it saves costs, it has higher return on investment. But at the point we decide, do we need the automation and what amount, we need to estimate the potential return on investment, correct? So in this case, let's have a little practice. Let's try to elaborate. I know we all are tired. It's been like 2 hours, 45 minutes past. We have like 15 minutes left in our time, but just like have a little bit rest and think peacefully about what are we gonna do in this case. So for example, we have the need, or we have like the proposition to switch from the Excel-based test cases to the test case management system. So we'll think, oh, let's buy some test case management tool and move this Excel-based test cases to the proper test management system. So on our project, there is 3,000 test cases as Excel files. Usually 100 of test cases are modified per week, which means modified, some of them are removed, some of them are added, and some of them are modified. So 100 together per week. Very rapid, very many changes. Okay, so we have a team of 10 QA engineers, and we estimated then 50 engineering hours average in a week we're losing due to a poor test case management, right? So what do we have here? 50 engineering hours, which means that every of 10 QA engineers losing 5 hours a week, just throw it off. And we do believe that test case management system solve this problem. So we can get these 50 engineering hours back because of this system. Because now we have lots of time paid for the duplication between those test cases. It takes time to find the proper one test case, etc. So we need that test case management system. Okay, so the good question is, when can we get positive return on investment? So when can we get this pure profit? So these tasks are like, well, are like classic tasks to do. So let's think about this. Let's try to draw let's draw some estimate to this. Okay, so what I'm going to do is I would just put this to my playground. Let's go by one. Okay, here. Oh, it looks ugly. Whatever. Let's take a look here. So, hope you see it perfectly. Let me put it this way. Okay. Yeah, that looks much better. So, what is? Let's try to evaluate these things here, and we'll see how it goes. So, okay, we're thinking about a test management system. Those are, some of them are paid, some of them are open source. Like, we can think about a test link, right, which is open source, or we can think about X-Ray plugin or Zephyr if we're using Jira, or we can think about something expensive like TestRail, or even that solution from Hewlett-Packard, from HP, HPLM, right? So we have a range of things to do. So we think, well, let's try to do it as fast as we can, as cheap as we can. So we say, okay, let's use TestLink. So if we use TestLink, we'll have some people with the experience. So we don't need to spend much time on this B, so it will be 0. But we need to make sure that this TestLink fills our requirements definition. For example, let's estimate how many time do we need to gather requirements and check, evaluate if TestLink fits to our needs. Let's say, okay, we will be having like 3 to 4 people that will take part in this evaluation requirements definition. So it will be like, let's say 4 people average. Each will spend, I don't know, 10 hours. So it will be like 10 hours by 4 people. So it'll be 40 hours. 0 here. And also we need to build some kind of a proof of concept to make sure we have our requirements fulfilled. That's my take. I don't know. Let's put it another 40 hours. See, how am I thinking about like 4 hours is good or not? Because I see here 50 engineer hours in a week are lost. So if we spend 40 hours on something, then in future can prevent this, why not? Still, so I could put 40 here for no problem. What about the training needs? So it will be here like 80 hours in total. The training needs. Technologies related to the tool, well, I don't think there are any complex there, so I can just put 0. People usually know about test cases and stuff, so 0. Training how to use the tool. Well, probably everybody in team should have some kind of a training. I would say maybe like couple trainings for the entire team. Entire team is 10 engineers. So we have like 40 hours initial trainings plus, I don't know, let's say like 40 hours totally for people to play with the tool personally. So I would say like another 4 hours, whatever. So it will be 80 hours in general for the training needs. And then come to licensing. So license fee is a 0, right? No problem. Then we come to infrastructure costs. Where are we gonna host it? So let's think where we're gonna host it on the cloud, and like cloud costs will be, I don't know, like $100 per month. See how to convert $100 to engineering effort. Simple. You know the rough salary of an average specialist, so you can compare. And $100 per month is very, very, very small thing. So we can just put it 0 because it doesn't mean anything here. So just 0, okay? Initial configuration. To put a tool, to install it for the operation system, to set up proper settings, it will take probably like one engineer, I don't know, several days at a time. Let's put it like, I don't know, 3-4 days. 3 days, let's say 3 days. A day there is 8 hours per day, so I don't know, okay, 25 hours. Then we need to move all our test cases to this system. We need to calculate. We have like 3,000 of test cases as Excel. So we need to do copy and paste, or we can use some kind of a bulk mechanism to move them properly. But still, we need to order them by test suites, etc. You know that, right? So let's go with, sorry. Let's think that test link have certain import mechanism that works perfectly with the CSV files. And there is a pretty much good XLS to CSV converter. So basically we can automate that. There will be some test automation efforts paid to that. I would say, well, to test it if it works from scratch, to do some modifications, etc., whatever, I would say that it will take, I don't know, like 50 hours, the initial automation effort, plus those are needed to be organized properly in proper test suites, in proper test plans, test runs, etc. So I would put another like 50 hours there, okay? And also some kind of ongoing maintenance efforts then can be like, I don't know, spent a week. So I would assume like I don't know, 10 hours for now. So let's calculate what do we have here. There will be 25, 100, 125, 125, 35 hours. So in total, we will have 40 hours, 160 and 135. So it will be like 300 hours, roughly, which is, if we divide it by 8, my brain is not working already, so I would use calculator. It will be 37.5 engineering days. So this team, 10 engineers, can complete it. If we divide it by 10 by certain time, but they should also actually work on their real project, right? So they should continue to do their regular tasks, correct? So let's say one engineer can, like 5 hours a week to dedicate to this one. Or whatever, we can calculate together and say, okay, we can split it by 2 weeks. So 1 week, we spent, let's say 15 engineer days, which is like we have 10 engineers, and we have like every day we have 10 engineer days. So basically together we have it like we can do it in 2 weeks. And see if we have if we are losing 50 engineering hours in a week, so we can have it back in only just 6 weeks, because we divide 300 of hours to 50 here, and we receive 6. So in 6 weeks, we can start gaining pure profit, and the estimated profit will be 50 minus 10. So we'll gain 40 engineering hours profit every week starting from 7th week. So if our project will work for 2 years, we can calculate how many hours we can save during this project. And this how many hours can be easily converted to money, because we know how average engineering hour costs. So this is the calculations that should be done regarding return on investment. It's completely different world, and for sure it doesn't being used every day, but this is the estimation that usually nobody talks about. And this estimation should be performed while planning big and risky activities, because at some point, for example, if in this case we put not like TestLink, we put like HPLM solution, right? So license fees, I don't know, HPLM is $40K per year, So if you convert this 40K to engineer hours, it could be completely different picture. And return on investment we can start gaining at least in 1 year, not less. So you know what I'm talking about, right? Anyway, this estimation should be like helpful for you. And of course, thank you for your time for today. I do believe that you received something interesting for you, something useful, something you can use in your work, in your everyday life. And Now I have to finish this webinar. Finally, we came on time. You know, my original estimate failed because I assumed 2.5 hours, but we have like 3 hours. Anyway, this is all about estimation. So if you have any questions left, you can ask it right now. I can continue to answer them. And if you don't have, you're free to leave. And I wish you like great day of time. Wish you success in your career and hope this helps. You can always find me on Facebook. I'm ready to answer your questions if you have and ready to communicate there, which is very important in our COVID times. So thank you very much for your time and stay safe and goodbye. I'll stay here for 2 more minutes just to wait if you have any questions.